Before we begin, have you ever observed how everyday objects moves in the air when tossed? If you would like to, go grab different items around you and try. Firstly, we have a ball. Next, we have a roll of tape. Then, we have objects like mobile phone, a table tennis racket, and a book. Are there any similarities or differences you observe between these demonstrations?
Hey there, I'm Waiz, and these are my groupmates, Yujie and Wanghong. And we are from the School of Science and Technology, Singapore. Today, we'll be sharing with you about the intermediate axis theorem. So, what is the intermediate axis theorem? It is also known as the tennis racket theorem and dubbed the Janabekov effect. In 1985, cosmonaut Vladimir Janabekov commanded a mission to repair space station Salyut 7. During the operation, he flicked a wing nut to remove it. As it left the end of the bolt, the nut continued to spin in space, but every few seconds it turned over through 180 degrees. Although the angular momentum did not change, the rotation axis moved in the body frame. The nut continued to flip back and forth, although there were no forces or torques acting on it. Interesting, right?
Before explaining further on the intermediate axis theorem, we will first explain to you about the axis and rotational inertia. You may have heard of axis before. In our three-dimensional world, there is three axes, x, y, and z. When objects rotate, they are rotating about their axis. Inertia is the resistance of any physical object to any change in its velocity. Newton's first law of motion, or law of inertia, states that an object will remain at rest or in uniform motion in a straight line unless acted by an external force. Thus, to change an object's motion, a force needs to be applied, and that force is different for different motions. Moment of inertia, or rotational inertia, tells us how difficult it is to change the rotational velocity of the object around a given rotational axis. Between the axis and the edges of the racket is larger, or in other words, the mass is distributed further away from the axis, the rotational inertia is larger, which also means that it is harder for the racket to change its speed. An object with its mass distributed near its axis spins faster than an object with its mass distributed further away from its axis, as it has a smaller moment of inertia. More torque, or force, is required to spin an object with a larger rotational inertia. Hence, it spins slower when spun with the same amount of force compared to an object with a smaller moment of inertia. Objects rotating about a distinct axis will have different rotational inertia. The intermediate axis theorem states that an object with three distinct principal moments of inertia, when rotating around its first and third principal axes, which has the lowest and highest rotational inertia respectively, is stable, while rotation about its second principal axis, or intermediate axis, which has an intermediate rotational inertia, is not. Due to the instability when the object is spun about its second axis, in a rotating frame of reference, while the object is spinning around the intermediate axis, the mass distributed furthest away from the axis is affected by centrifugal force. This causes the masses to accelerate for half the spin, then decelerates till the masses stop spinning. This is happening while the object is still spinning about its intermediate axis. With enough airtime, this effect could repeat on and on.
So here is what we have come up with. A frisbee with a weight, in this case a lock, attached to it. Without the lock, the frisbee will only have two distinct principal axes, whereas with the lock attached, it has now three distinct principal axes. Now, with an intermediate axis. The object tossed to spin about the intermediate axis will be unstable, causing it to want to stabilize and move weirdly.
Janabekov discovered this effect in 1985, but Russia kept it secret for 10 years. Why, you may ask? This is because Russia thought that Earth as a rotating mass may experience this effect too. However, this is not true, as Earth has been spinning for a long time and has settled in an axis of maximum inertia, spinning stably. So, there is no need to worry. We have come to the end of the video. Thank you so much for listening to the end. We hope you learned something from this video. Stay safe and stay curious.